So when we put AI systems into really important environments, think manufacturing, think labs, how can we actually be sure they're operating safely? The answer isn't just about building a smarter model, it's about building in the ability to see what that model is doing. In this explainer, we're going to break down why visibility isn't just some nice-to-have feature, it's an absolutely critical, non-negotiable part of the design. All right, let's get into it.
I want to start with this quote because it just perfectly nails the core of the problem. Big, catastrophic failures, they almost never just happen out of the blue. They're usually whispering for a while first, giving off these subtle, quiet signs that something's not right. The real question is, are we even listening?
And that goes double for AI. These systems can be unbelievably complex, and their behavior can shift in ways we just don't see coming. So if we don't have that visibility, we're essentially just flying blind, waiting for that big, loud failure instead of catching those first silent warnings.
So to get that visibility, we've got to get our heads around two key ideas that people often mix up: monitoring and observability. They might sound like the same thing, but the difference in how they work is absolutely fundamental to running AI safely.
So what is the difference? Well, monitoring is all about keeping an eye on the things you already know to look for. Think about the dashboard in your car. It's showing you your speed, your fuel level. These are known, predefined signals. Observability, though, that's your secret weapon for exploring the unknown. It's the power to ask your system brand new questions to figure out why something is happening. So when your car starts making that weird noise, observability is what the mechanic uses to actually diagnose the problem, not just read the dashboard.
And this is the absolute key when it comes to AI. Because AI behavior isn't static. It can drift and change over time. Just watching for predefined failures is nowhere near enough. We need observability to understand all those subtle shifts and weird new behaviors before they spiral into real problems.
Okay, so if observability gives us this power to explore and ask questions, how do we actually turn that into a real active safety mechanism? Well, that's where detection comes in. It's all about making our visibility something we can act on.
Which, of course, leads to the big question. If we're trying to catch things we don't expect, what exactly are we supposed to be looking for inside these complex AI systems? What are their vital signs?
What's great here is this gives us a kind of checklist. We need to be able to see the inputs the AI is working with. Has the data changed somehow? We need to watch the outputs. Is the model suddenly making different kinds of calls? We absolutely have to see its confidence levels. And finally, we've got to track the paths it takes to make a decision and watch for that slow drift over time. Think of these as the windows into the AI's mind.
So with all that data streaming in, detection is the active process of actually spotting the weird stuff. This means we have to set clear rules. For instance, if the model's confidence suddenly tanks, or its predictions swing wildly, a detection mechanism fires off an alert immediately. It's the system's own automated alarm bell. Now, let's put all this in a real-world context. What you're looking at here is a typical setup with IT systems and OT, that's operational technology systems. On the left, you've got IT, where all the data lives and the AI models run. But on the right, you've got OT, that's the actual physical stuff, the lab equipment, the factory machines, the process controls. This is exactly the kind of environment where an AI's decision can have very real consequences. Everything we've been talking about so far, observability, telemetry, detection, it all builds up to this next point. And honestly, this is the most critical idea in this whole explainer. The unbreakable link between how much authority an AI has and how much visibility we absolutely must demand from it. To put it as simply as possible, the more power you hand over to an AI, the better your view into what it's doing needs to be. It's a trade-off, and it is not negotiable. As the potential for that real-world impact gets bigger, so does our need for strict, real-time supervision.
Let's go back to our diagram. See how the IT side is highlighted? If an AI is purely assistive, meaning it's just hanging out on the IT side, offering up some analysis or maybe a few suggestions, the risk is lower. A problem here isn't a catastrophe. Basic monitoring is probably fine in this case.
But now, look at this. The second that AI is given the authority to reach across and influence the OT systems, to actually change a process or control a piece of hardware, the entire game changes. The stakes are just infinitely higher. Now you absolutely need lightning-fast automated detection and crystal-clear response plans like stop the process or escalate to a human operator. It's a perfect illustration of how that authority boundary totally changes the rules of the game.
Which brings us to our final and maybe most important point.
All these concepts, observability, detection, authority, they aren't just boxes to check after you've built something. No, they're a mandate. Visibility has to be a foundational piece of your design process, right from the very start. I love this quote from the source material. It's such a powerful reminder that building a black box AI that nobody understands, well, that's a choice, and it means we can and we must choose to build systems that are transparent and observable from their very core. So how do we actually do it? Well, here are 4 really practical steps. First, you've got to build in telemetry at every single point the AI makes a decision. Second, make its confidence score a first-class observable metric you can track. Third, build the tools to analyze trends so you can spot that slow drift. And finally, plug all of this directly into your incident response process so that when an alert goes off, something actually happened.
And as you're designing, please watch out for these common traps. First, just having a pile of logs is not the same thing as having observability. You need to be able to explore that data. And second, don't just monitor for when things go right. Failures almost always live in those messy, weird edge cases, so make sure you're watching those places like a hawk.
Now, it's really important to be clear about something. What we're talking about here are core principles, not specific products or prescriptions. This information does not authorize you to go deploy any particular system. The goal here is to prepare you to design and build AI systems that can be safely seen, safely controlled, and, at the end of the day, trusted. And we'll end with this one crucial thought. If you want to be able to govern AI, if you want to make sure it's operating safely and doing what you want it to do, you have to be able to see it. Monitoring and observability, they're not just technical jargon. They are the absolute foundation of trust and control.